It's your friendly math tutor, Miss C here, and today we are looking at simplifying exponential expressions in this very quick video. We're looking at a lot of different problems, so let's get started. We have a to the fifth times a third. Notice that our bases are the same. They're being multiplied. They have different exponents. We add the exponents in this rule, so we end up with a to the eighth. So we added 5 and 3 together to get the 8. Notice in our next example, we have 4a squared plus 6a squared. This is addition. It's not multiplication. We cannot use our exponent rules. What I do notice is that since my variable and my exponents are the same, these are technically like terms and they can be added. So when I have 4a squared plus 6a squared, that gives me 10a squared. Okay, we combine like terms. Our next problem is a power on power rule problem. We have a to the fourth raised to the fifth. This means that we are essentially multiplying a to the fourth by itself 5 times. The shortcut here is we multiply our exponents and we get a to the power of 20. Same idea on our next problem, a to the sixth times z to the seventh, all of it raised to the eighth, except we have to apply this power of 8 to each variable. So we end up with I'm multiplying 6 and 8 to get my exponent of 48. I'm going to do the same thing with z. 7 times 8 is 56, and there you go, it's simplified. Shifting to division, when we have the same base, so we have a, you're going to notice these are all same bases when we're combining. We have a, and we subtract our exponents. When we've got division, 9 minus 7 is 2, so we end up with a squared. Sometimes we'll have a coefficient in front of our division problem, and we just divide these. 10 divided by 2 is 5, and then we apply our rule. A to the eighth divided by a squared means that we say 8 minus 2 for our exponent, and we end up with a to the sixth. So 5a to the sixth is our simplified answer. And our final answer, I'm noticing that my exponents are a to the seventh in both of these. That means these are like terms. And when we have like terms, we subtract. So we're not applying any exponent rules. I just want to point out here, this is not a division sign. It's not a multiplication sign. It's a subtraction sign. That's why we're combining like terms. When I do that, I have 10a to the seventh minus 13a to the seventh. That gives me negative 3a to the seventh. If you found this video helpful, please like it so other people see it. Make sure to subscribe so you don't miss a video. Till next time, remember, you've got this.